Okay, so this is going to be a simple tilting maze puzzle. So like those old handheld games where you used to tilt it around and you had like a little BB that would roll around and you had to avoid little holes and you had to get the BB to the exit. Similar to that. So let's start. Now this is similar to what you're going to see when you first create a new 3D project. I'm just going to rotate our camera around so that it's behind the player camera. That way, as we're developing this, as we're making this, we'll already have a sense of what the player will be seeing. And it's just a combination of left clicking with the hand and right clicking to rotate around. Now what I just did does not change what the player sees, because this here is the player camera. What I changed is our director camera, for want of a better term. So let's create the basic platform. So game object, 3D object, cube, and we're going to center everything at 0, 0, 0. Now it doesn't need to be that thick of a cube. So let's make it 0.1. And now let's scale out X and Z. You might want to make it bigger than that, but once you get the basics, you'll know how big you're going to want this. So next we need our orb. So game object, 3D object, and sphere. We'll also center that at 0. We'll put that at +1, so we're going to have it just above the platform to begin with. And 0. Now, right now, both objects have a collider. This one has a sphere collider, and this one has a box collider. What they also need is they need to have the ability to apply physics. So box colliders and sphere colliders, they allow for a collision, but there's like no force. There's no momentum. So to move objects, that would be a rigid body. So both of these need a rigid body. So physics, rigid body. Now in the case of the cube, we're not going to use gravity, and we want it to be kinematic because it needs to be a suspended platform, that the orb bouncing around inside of it should not move it. The sphere also needs physics, rigid body. This one we do want gravity, and we do not want it to be kinematic because we want it to roll around. Okay, so far so good. Now what we need to do is we need to start controlling this platform. Actually, before we do that, let's tweak the size of the sphere. In the scale, I'm just going to change it to 0.8, 0.8, 0.8. That's better. And just so you know that physics is working, I'm just going to raise the orb so you can see it drop. So it drops, it stops, so it has gravity. The platform itself did not move, so it's kinematic. Now what we need to do is we need to move the platform around, causing the orb to roll. So right click, create, C#, and we'll call this tilt. We're going to click on the sphere. Oops, sorry, my apologies. We're going to click on the cube, and actually let's call this platform. So drag and drop the script onto platform, and then go ahead and open it up. So what we need now is we need to be able to check for input from the controller. So let's take a quick look at how the controller is handled by Unity. So if you click on Edit, you click on Project Settings, and you click on Input, you can see it says Axes here. So what it does is it actually treats the various analog controllers and even the left and right trigger as axes. And it's not binary, it's not 0, 1, on or off, it's actually a range. It's a range from 0 to -1 and 0 to 1. And depending on what one you're looking at depends on what the values are. For instance, the triggers, one trigger is 0 to -1, the other trigger is 0 to +1. On the analog controller, say the left analog stick, left is 0 to -1, pressing right is 0 to 1. Likewise for the vertical on the left analog stick, up is 0 to 1, down is 0 to -1. Now the reason why I'm talking about this is because nowhere in the coding that we're about to go through do you ever see the code that says left analog stick or right analog stick. What you see is this, horizontal or vertical. Now you can change the name of this, but it doesn't change the fact that Unity sees the analog sticks as actually two independent axes. So rather than seeing a left analog stick that's giving you a single input, you're actually checking the left and right, so the horizontal axis, and separately you're going to check the vertical axis. So it's a little odd at first that you don't see any coding that explicitly references the analog stick, because that's why it actually treats it as multiple axes as opposed to a single input. So what we want is if input, and as we said, it's get axis, which axis, as you saw, the term was horizontal, their name was horizontal, and if it's greater, we'll say 0.2. Now that's completely and utterly arbitrary. So why not greater than 0? Simple, because sometimes you don't want a control to be too sensitive. Like in some fighting games, sometimes a super attack will go off and I barely even touched the trigger because it had a very low threshold. So by adding this dead zone, which would explicitly be 0 to 0.2, if you have a little bit of pressure that returns those values, nothing will happen. It's not until you exceed 0.2 that something happens. Again, completely arbitrary. You don't have to do that if you want. I'm just thinking of, the way I play games, that sometimes too sensitive is bad. Okay, so if we have a horizontal input that exceeds 0.2, then we want something to happen. What do we want to happen? Transform.rotate. And we're not going to rotate it on X or Y. So even though we're talking horizontal, you'll see in a minute why it's this way. We're going to actually rotate on the Z axis. And if we're doing +2, then let's say we want it to rotate 1 degree. Okay, this will functionally work, but I do want to point out that the update section happens once per frame. So if you've got a system where this is a higher frame rate, it therefore will rotate faster because you're having more frames per second. So in a final version, you really wouldn't want it to be just like that. You would want to do some time control as well, but this is good enough for demonstrative purposes. So now we're just going to reverse this. If it's less than -0.2, then we want it to move -1. All right, let's run it. So I'm going to press on the controller. There it rolls, and press on the controller, and it rolls. So you already have the basics. You can, as you can see, that indeed gravity does take it off the edge. So now what do we want to do? Well, that's as far as the basics, the environment is now set up. Now it's just a matter of like making your maze. And that's just really creating blocks and putting them wherever you want. So let's do a cube. And let's put this into the center. So 0. We actually want this above the maze, so we'll put this at 1. We'll put this, it looks really high because it's pushed in the background on the Z-axis. So when we change this to 0, you can see it's actually much lower. So if you grab the blue arrow there, made it look like it was higher, but in fact it's actually almost on the ground. All right, so what we're going to do is we don't want it to be that thick in either direction. So that tall, we'll have to think about that. But as far as the X, let's make that say 0.2, and the Z 0.2. Actually, no. Z we want as 1. So this would be like a horizontal. So this would be like a wall for depth. Okay. And let's just make the full border actually. So let's make this. We said the other one was what, 10. Okay. So now we copy that. We paste that. Move that over. No sense reinventing the wheel. Copy that, paste that, rotate it. Whoops, wrong one. Nope. Third time's a charm. There we go. So now you have the basics. Now we copy that and paste that. Bring that one here. Now it's not very easy on the eyes because everything's white. So let's start changing that. So let's add a new material. This is the default material. So right click, create material, and we'll call this metal matte for metal material. Come up here, go to metallic, increase that there. You can already see how it looks different here. Increase the shininess or smoothness, excuse me. If you want to make this more of like a silver color. Okay, now we go to our sphere, drag and drop that to replace the default matte, and suddenly now it doesn't look so bad. Let's run it. There you go. So we'll use the controller. Okay, so see what happened? The borders did not move with it. So that's the next concept I want to introduce, and that's the idea of parenting. So you can parent or child an object to a parent. So how do you do that? Grab those 4 cubes, drag and drop them onto the platform. See how they're indented now, and there's the down arrow? So when you do something to the platform, it now cascades to the children. So watch this. If I move the platform, now all the children move. So let's do that again. See? So I really wanted you to see it the first way, with them not moving. That way you can really see what a difference it makes. Now let's tilt on a different angle. So that's the Z. Now we want to tilt it on, I'd say, I believe the X. So how do we do that? Well, you can copy and paste this, although we have to go change a couple things. So now, the other one was called vertical. And we'll use the same threshold of 2, of 0.2 and negative 0.2. But we said that we wanted to rotate on the x-axis, not the z. And let's just go to project settings, input. There we go. And if you notice, vertical. So this was the first one we checked. Now we're checking for that. So now if I press up, press down. So there you go. That is the basics of making a 3D maze, or a tiltable 3D maze. Now there's certainly other things we have to do. Like for instance, there's no limitation. Like I can tilt this all the way around and dump it. Probably don't want that to happen. So in the next video, we'll do some controls. I didn't really want to get that in the first video. I just wanted to show you about transferring the input from the device to the object Now we'll put in, or should I say next we'll put in some controls as, okay, don't let it tilt beyond a certain angle, that kind of thing. Okay, and if you have requests, just let me know.